The formation of the moon. Since ancient times, the moon has aroused men's curiosity. For the Guarani, one of the most representative indigenous ethnic groups in the Americas, the moon was a goddess called Jackie, protector of plants, lovers and reproduction. Mythologically, Jackie is identified with Diana of the Romans, Xochiquetzal of the Aztecs, Chandra of the Hindus and Isis of the ancient Egyptians. The Mayan civilization, a pre-Columbian people from Central America that reached its peak during the period from 250 AD to 900 AD, also linked the moon to femininity and fertility. They had advanced knowledge in astronomy and mathematics and mapped the moon's movement with extreme precision. In our recent history, we sent astronauts to the moon to study it better. Such fascination arouses us. With all this admiration throughout human history, we are led to ask ourselves, how did the moon appear? Several theories have already emerged about this. Co-accretion theory. It proposes that the moon formed around the Earth early in the formation of our solar system. After the formation of the Earth, there would have been material left over, which gravitated around it and, over time, ended up agglomerating and forming the moon. The justification for validating this idea is that the satellite and our planet have some characteristics in common, such as the age of the rocks on both surfaces. However, there are significant differences that remain unexplained, such as the lower amount of iron found in lunar soil. Capture theory. It proposes that the moon would have formed far from Earth, but would have been captured by the gravitational force of our planet as it passed close to it. However, calculations demonstrate that such capture by the Earth's gravitational attraction is practically impossible for an object as large as the moon. Fission theory. According to her, the moon and the Earth would initially be one body and our satellite would have detached from the Earth. Still incandescent, the Earth would have started to rotate around itself, at a speed much greater than that occurring today, and thus still hot pieces were thrown away. The theory claims that the region of the Pacific Ocean corresponds to the part that formed the moon. The idea is not widely accepted because the oceanic space would not be enough to compose a star the size of the moon and, if it had actually detached itself from the Earth, its orbit would be different. Big collision theory. The main theory of the formation of the moon dates back to 1975 and considers that a celestial body the size of Mars, called Theia, collided with the Earth about 4.5 billion years ago, when our planet was still forming and was a big ball. Pasty and hot. A piece of the Earth's globe would have broken off and formed the moon. There are also variations of the theory, which consider that various debris from this collision accumulated around the Earth and, over time, due to gravitational forces, came together and eventually formed the moon. This primordial moon was very different from our current satellite, as it was still in a state of fusion, that is, it was formed from non-solidified magma, which, over time, crystallized. The moon also rotated much faster than it does today. However, due to the gravitational interaction of the Earth-Moon system, their translation and rotation speeds decreased to the point of becoming equal, thus maintaining the same face of the moon towards our planet. This is why we always see the same side of our natural satellite. Multiple collision theory. It proposes that, rather than a single colossal collision, a series of impacts created miniature moons largely from Earth material. These mini-moons have merged over time to form one large moon. This is the most recent hypothesis, from a study published in 2017 in the scientific journal, Nature Geoscience. Even though we still don't know for sure how the moon was formed, we can be sure that our lives would be totally different if our satellite didn't exist.